So what do we do when the angle is not a multiple of 0, pi, or pi over 2? In other words, how do we deal with the more complicated questions like finding exact values of sine or cosine or tangent of things? And it actually comes from, before we were looking at a unit circle. And the unit circle meant that it had a radius of 1. So if I drew some sort of little, little line right here, this radius right here, this was r, and this right here was actually 1. Like this little radius right here was 1. This value here, this radius. Now what we can do is, rather than just have a unit circle, which means the radius always has to be 1, now we can just extend it. So we can extend this unit circle to any radius r. So what we're going to do now, we're just going to extend it. So we're going to say, all right, let's make it go even further. So we'll make it, I don't know, maybe go out to here somewhere. So some value like this right here. So we can just extend this. And if we did that, we can maybe multiply then by, see how now, for example, we're multiplying it by some sort of scale factor. I don't know, maybe I'll call it h just for some sort of scale factor here. Well, if that's the case, then instead of before where the x was just cosine of the angle, now it's going to be h cos theta. And where this one right here used to be just sine theta, now it's going to be h sine theta. In other words, we're just going to multiply by some sort of scale factor. Now, lucky for you, you don't really have to worry about what that scale factor is. I just wanted to show you why it is that we're leaving a unit circle. Now we're going to make triangles and things that are going to help us out regardless. I mean, they don't have to have a radius of 1. This is just because it's going to be able to help us for other things. So if this was confusing, no problem. Just forget about this. Let's just move on to what's the important part. We're going to learn about two things. Now, in order to solve these big kinds of questions, there are lots of ways of doing it. Teachers teach all sorts of different ways of doing it. But I'm going to show you this. When solving the really tough questions like sine, cosine, and tangent, you can use the following. So you don't have to. This is how I personally do it. I'm going to draw the angle on the unit circle. And then I'm going to use my special triangles, which no longer necessarily need the unit circle. But I'm going to use special triangles to almost get me the answer. And I'm going to make sure with quadrants that I know if it's positive or negative or what it should be. Now, I'm going to show you what I mean by special triangles and quadrants. There are other methods of doing this where you just memorize a table and things like that. But I'd rather try to show you a little bit more graphically what we're doing. So you will still have to memorize this special triangle, but that's it. And I think it's very little to memorize. So what do I mean by the special triangle? This is super and duper important. So there are two of them. There's one that I would say is the, whoops, what happened here? I'm going to try to draw it actually with a straight line maybe. There we go. So there's two special triangles. One of them is when the angles, now here I'll just, let me just label this here. So this right here is 90 degrees. And this one right here is 45 degrees, and this one right here is 45 degrees. And this one says that if this value is 1 and this value is 1, then think about Pythagoras' theorem. This would be 1 squared plus 1 squared. That would be 2. So this right here would be 2 squared. So that means this one right here then would be square root of 2 would be the length here. That would be the length of this thing. If you're not sure, again, just go c squared equals a squared plus b squared. Where this here was 1 plus 1, of course squared. That means c squared was just 1 plus 1, which is 2. Therefore, c is square root of 2. Plus or minus technically, but we just use the positive. So the key thing from this special triangle here is this, that it goes 1, 1, square root of 2. This is going to come in really, really handy. This is going to be so important. So what I'm going to do, I'm going to draw it with this around it because this is so important. This is your 45, 45, 90 sort of thing. This is your first of your two special triangles you need. Now the other one we need is a different looking triangle. I'm going to attempt to draw it like this. Make this here like this. And like that. It's not perfect. It's not exactly to scale. But that's okay. Good enough. This is still 90 degrees. Whoa. I should not have done that. I need to change my pen. There we go. So I need to make this, maybe I'll make it in black. So I'll make it 90 degrees. And this one, however, this one here is 60 degrees. This one here is 30 degrees. And this one goes a little bit different. This one here goes 1, 2, and square root of 3. 1, 2, square root of 3. This is the other special triangle. Really helps to memorize. So I'm going to suggest you actually learn it. And maybe I'll just drag this whole thing down a little bit so I can fit it a little bit nicely. Oops. This. Put it down here. This way then I can actually draw really nice things around this one. These are the two things that are really worth learning. Now you can always double check that this actually works. You can check that by again doing the math here. You can say this one right here, this is the hypotenuse, so you should check that. Does 2 squared really equal 1 squared plus square root of 3 squared? Well, 2 squared is 4. Let's see if the left side equals the right side. The right side is 1. Square root of 3 squared is just 3. So 4 does indeed equal 4. Yep, this works. So this is a real triangle here. This could work. And in fact, this is the one you should use. Now I'm going to explain to you why in the next set of videos. I'm actually going to put all these in action. But for right now, I just want you to learn the tools. You need to have this in your toolbox, so to speak. At least if you're going to learn it the way I'm going to show you. So you need to know your special triangle. So it's 45, 45, 90. And this you get a value of 1, 1, root 2. And if it's the 30, 60, 90, then it goes 1, 2, root 3. And the 30 degrees and the root 3, they're sort of beside each other, because this is the hypotenuse. So the way I remember is this is the one that gets the root 3 here. This, or you just memorize it. But 60 goes here on the bottom, then it goes 1, 2, root 3 like this. Now what else can we use? We can use what are called quadrants. That's the last thing. Now this may not make sense just all together. You're going to say, why is he showing me this? It's because I'm going to put them all together really nicely, hopefully, afterwards. But you need these tools. So first you need special triangles, and the other thing you need is quadrants. So what do we mean by quadrants? So we've actually defined the different quadrants here. We have X and Y. Turns out we call this one right here is called actually quadrant 1. Technically this is called 2, this is called 3, this is called 4. However, we have a trick. People call this cast rule. And here you have to start off, the C has to be here, the C, A, S, T. So some people call it cast. Although if you're used to calling it in quadrants like this, it'd be A, S, T, C. One of my teachers told me, I was like, all students take calculus. It's like, well, whatever works for you to remember this. But you got to know about this A, S, T, C. You got to know that it goes like this. So make up your own mnemonic or your own way of remembering it. But you got, I mean, the quadrant itself, quadrant 1, 2, 3, 4, I think is less important than knowing what letter this is. And there's a reason why. So we have to know that this is S, this is T, this is C, this is A. This is really important here. What do these stand for? This means that all are positive in this quadrant. What do I mean by that? I mean that cos and sine and tangent of an angle. So if I have an angle that finishes here, so let's say I have an angle that's like this. Then if I want the sine of that angle or the cosine of the angle or the tangent of the angle, the answer is going to be positive. Why? Because this is in the quadrant where all are positive. If you finish over here, so what if your angle goes to where you're sort of stuck, you're over here? Then S means only sine is positive. In other words, cos and tangent are negative. That's what this means. So if you're in this quadrant, if you take the sine of an answer, sine of an angle that's in this quadrant, then you're going to end up with a positive sine, but cos and tangent are going to be negative. Over here, I think you can guess then how this goes. This one over here is only tan is positive. Here, only cos is positive. In other words, here you could say that because only tangent is positive here, well then you would say then that the sine and cos are negative. And here, if only cosine is positive, then you could say that sine and tan are negative. So this is how we use those quadrants. So we look at if your angle finishes somewhere in here or somewhere in here or here or here, then you can tell if your answer is positive. Which is actually good because you can work backwards. What if you get an answer and you get some sort of answer and you know it's positive, then there are actually two places where it's positive, where it's possible to be positive. So there's here and then maybe one of the other quadrants. So I'm going to show you in the next set of videos how to put this all together. But I just want to tell you, here's how I solve questions. No matter what it looks like, if they're really, really tough ones, this is how I do them. I do step 1. I draw it. I draw it on the unit circle and I do what's called a reference angle. What I mean by that is that, let's say, for example, I drew it and it ends up over, let's say it ends up over here. Then what I would do is I would say my reference angle will be this value. I would do an angle of like what's from the x-axis here. And I'll explain that in context later. Then I use special triangles. That gets me the answer. Just about. So that gets me like, oh, let's say I want the cosine of 45. Well, cosine is adjacent over hypotenuse, so I know it's 1 over root 2. Or what if I want, I don't know, the sine of 30? Then I would say, oh, sine of 30. Let's see, sine, that's so kato. So that sine is opposite over hypotenuse. So sine of 30 degrees is 1 over 2. So that's the second step I do. It almost gets me the answer. But you got to check with your quadrants that is it positive or negative. In other words, you got to double check that your answer is positive or negative, or are there multiple answers possible. This is where you check with your quadrants. And if you just do this, you draw it first, look at special triangles, and then look at your quadrants. This is a good way to get through most of the really, really tough questions.